Hello everyone, my name is Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is sum of leaf nodes in binary search tree. First of all, let us start by understanding the question. What does question say? Given a binary search tree with n nodes, find the sum of all leaf nodes. So basically we have a binary search tree where there are n nodes and we want to find the sum of all leaf nodes. Binary search tree has the following property: duplicate nodes are possible. The left subtree of a node contains only nodes with keys less than the node's key. We know this property. And the right subtree contains values greater than the current key. Okay. So the right subtree of a node contains only nodes with keys greater than or equal to node's key. Okay. Your task is to determine the total sum of the values of the leaf nodes. So for example, if this is my binary search tree, what is the meaning of leaf node? Which doesn't have any children. So here the leaf nodes are 12, 45 and 78. So the total would be 12 plus 45 plus 78, that is 135. Similarly, here there is only one element, it in itself is a leaf node, so output is 45. You don't have to take any input or print anything. You are required to complete the function sum of leaf nodes that takes root of a binary search tree with n nodes as parameter and returns the sum of leaf nodes. The expected time complexity is big O of n and expected auxiliary space is constant. So if we think about solving this problem, then basically we are given a binary search tree for example, if this is, let's say, 100. Now what is the property of binary search tree? All the nodes in the left subtree must have value less than this node and all the values in the right subtree must have value greater than this node. So let us say here there is 70, here there is 120, here let's say there is 110, here let's say there is 140, here let's say there is 130, and here let's say there is 150. Similarly, here let's say this is 60, here let's say it is 80, and here let's say it is 75. Okay, so it is following binary search tree properties. We want to return the sum of all leaf nodes. What are leaf nodes? The nodes which do not have any children. So 60, 75, 110, 130 and 150. These are the leaf nodes. So our answer should be 60 plus 75 plus 110 plus 130 plus 150. So that should be our answer for this tree. Now we are given the pointer to the root node of the binary search tree. So how can we solve this problem? We can recursively traverse the tree, and if a particular node is a leaf node, we will return its value. Otherwise, we will return the sum of its children. Okay. So for a non-leaf node, it will not return any value. So for example, let's say if this is my function int, let's say I'll call it recursion, which has the pointer to the root node. Okay. So first of all, I will say if the root node in itself is null. So if root node is in itself null, then I will return 0. Okay. Now, if it is not null, I will check if it is the leaf node. If it is the leaf node, how will I know that? If the left subtree of this root node is null, leaf node means which do not have any children. So if the left subtree is null and right subtree is also null, then in that case I can say return root data. Why? Because this is a leaf node, so we want to count it. And if it is not a leaf node, then I will call its left children and right children and return their sum. Okay. So if it is not a leaf node, then I would say return recursion on root left plus recursion on root right. Okay. So it will traverse the left subtree and right subtree, and again from there it will return the sum of the leaf nodes. So for example, if I look here, is this a null node? No. Is this a leaf node? No. So it will call its left subtree and right subtree. Now is this a leaf node? No. So it will call its left subtree and right subtree. Is this a leaf node? Yes, because its left and right children are empty. So this will return 60. Now is this a leaf node? No. So it will call left and right children, but there is no right children. Right children is null, so it will return 0. Now this is a leaf node, so it will return 75 and this will return 75, which obtained from this. Okay. Now this will be 60 plus 75. Okay. Left child plus right child. So 60 and 75 is how much? 135. So this will return 135. Similarly, the right subtree will get processed and all the leaf nodes sum will be accumulated and returned by the root node. What would be the time complexity? The time complexity here would be big O of n, because every node is visited once, at most once, and even if you consider the recursion stack, it will contain at max n elements. Okay, and what will be the auxiliary space? It will be constant, as we are not taking any arrays or something. Okay, now let's look at its actual implementation and submit the code. So if we look at the actual implementation, so again, if we are given the pointer to the root node, if root is null, return 0. If its left and right child are null, it means it is a leaf node, then return the root data. Otherwise, return the left subtree sum and right subtree sum. Okay, so it will recursively go in the left subtree and right subtree and calculate the sum of leaf nodes from left subtree and right subtree, combine them and send it to the above node. Okay, now let's submit it. Let's submit it. Okay, so we have solved this question successfully. I hope you have understood the solution completely. Thank you.